Hi everyone, can you all hear me?
Yeah, we can hear you.
Alright, I'll just share my screen. Uh, just a second, guys. Alright, uh, can you all see my screen, the whiteboard?
Yes.
Alright, so first, today's topic is prefix sums. I will also be including some closely related things like um, difference arrays and 2D prefix sums. So lecture will go something like this. I'll start with explaining what prefix sums are and what difference arrays are. Then we'll move on to some of the questions. I have sorted them as easy, medium, and hard. Um, I will probably be discussing the easy ones and the hard ones, skipping over the medium ones. If you have any doubts in the medium ones, you can ask me at the end of the lecture. All right. So let's start. So first, let's think of a sample problem. I'm sure you know what an array is. Let's say you have an array and you're given the problem that you will be given q queries. In each query, you have to tell the sum of a certain subarray. Subarray means like between some indexes L and R, the sum of all values like AL plus 1, AL plus 2 up to AR. You need to tell the sum of those values. So first, tell me how you would go about solving this particular question. You can answer in the chat. No, its first index can, let's say, be anything. Um, yes, but so the prefix sums is indeed the optimal way of doing it. Advik already knew that, but I'm assuming most of you would have first thought of just iterating through all the elements and like adding them one by one. So solving each query would take order n, and therefore this would be order nq. But there's a better way of doing this. Essentially, as Advik just said, I don't think you could understand from just his notation. Prefix sums essentially means that we create another array like the prefix sum array. I'm sorry for my drawing. Um, this array will include like the first index of the array would include the sum of the elements 0 and 1 in your original array. For example, if we have the array 3, 8, 7, 4, then its prefix sum array would look something like 3, then 3 plus 8, 11, then 11 plus 7, 18, and 18 plus 4, 22. So I'm sure you're wondering how this helps us solve the problem. Essentially, you can think of it like this. If we have an array, I'll just draw it as a line, and I need to tell the sum of this subarray. Then you can think of it as two operations. Um, you would think of it as the sum of this array minus the sum of this subarray, which would give you this part, right? This is what essentially this is pre-computing some values which will help us in answering the query more efficiently. So that is all right. I'll repeat once. Essentially, it just means that prefix sum means that it is the sum of the prefix of the array up to this point. Like this first index would be the sum of the values a0 and a1 if the array is called a. The second index would be a0 plus a1 plus a2 and so on. And that's what prefix sum means. And this is how it can be used to solve uh, this specific problem. Now the formula is looks something like this. Like if you have to find the sum between L and R, it will be pref. I'm using pref to denote the prefix sum array. Pref R minus pref L. It's slightly more complicated. Like you have to add some element if you want to. Like this also deletes the Lth element. So you could add plus AL in the end. Uh, so this is essentially what prefix sum means. This is not just limited to sums. For example, you could also have products, uh, or in one of the problems there is a GCD as well. Essentially any operation that can be like you can take two values and get their difference sort of like just like this. You can use this method in any such use case. So does everyone understand what prefix sum is? Uh, yes, like at least this basic form will only help in such a case. All right. I think most people understand. So if anyone doesn't understand, then feel free to say it. Right. So like this can be used in this sample problem that you're given an array and you're supposed to you will be given multiple queries, and in each query you're supposed to tell the sum of the elements from some index L to some index R. These indexes will keep changing for every query. Um, all right. The question. Yeah, the question is just like, uh, let's say you have an array 3874, then you'll get queries that would look like 1, 3 would mean you're supposed to give us the 8 plus 7 plus 4, the values, and 0, 1 would mean 3 plus 8. That's like the question. You will be given multiple such queries which you have to answer. Um, This is just prefix. Suffix sum is just prefix sum, but like it's the array is flipped. This can be applied to multiplication because like in multiplication you can just instead of the sum up to some index I you can store the product and then you can divide pref r by pref l. Of course there will be some like if you have bigger numbers then there might be overflow and all, but not that's not what I meant there. Like usually there will be a modulo as well. Why do we add AL? That's because pref L also includes the Lth index. That depends on your implementation as well. So in this particular case, you have to add AL back. Like let's say I'm supposed to give, I'm given 1, 3. Then I'll subtract 22 minus 11. That gives us 11, which is just 7 plus 4. It's actually the answer for 2, 3. So you have to add 8 again in this sample. Right? Okay. Yes. The use is just to improve complexity. This is like NQ versus N is usually something like N square versus N. All right. So I'll just do an like move on to the next topic for now. So this prefix sum, still now I've told you how it works for a one-dimensional array. Like you just have one list of numbers. Let's say you actually have a grid of numbers. All right. I'll just draw a grid. This is known as a 2D array. I'm not sure if this has been explained in the previous lectures. It's essentially just an array of arrays. Like you could have like these cells are just filled with values, and now let's say the question is to get the sum of some values in a specific subrectangle of this grid. Like let's say over here. I think I should change the color. Let's say we have to get the sum of some values like here. So you can use a similar idea to the 1D one, except now instead of storing like you were just storing up to index I in the prefix array, now you will be storing like let's say it will be a 2D array now. So let's say in this index you will be storing the sum of all of these values like in this rectangle from 0 0 to here to whichever index like the value the prefix sum index. Alright. Now so the formula for a 1D array was just pref r minus pref l plus al, but when you increase the dimension it gets slightly more complicated. So for example, in this case you would be using I'll first show you diagrammatically. So you could have like the bigger rectangle I've drawn. I think I should use different colors for this. So you need the answer for this rectangle. Can you see that color? It's probably a bit too big. So if you want the sum of the values in this specific rectangle, then you could find like using the pre-computation we've done, you would already know this sum of values in this rectangle, like the bigger one up till here, this rectangle and this rectangle, like up to here, here and here. You should already know the values using the prefix like pre-computation for prefix sum. Now using these three values you can, and this one as well of course, Using these four values, you can find the sum of this rectangle. Um, what you could do is take this value, which is the sum of all of these, like the biggest rectangle I've drawn. Take that sum and subtract this one, like up till here, and this one. But this subtracts this region twice. So you have to re-add that again in order to get the sum of this rectangle. Alright. Uh, I think I'll show you the formula as well. Let's say you're supposed to x1 comma y1 to x2 comma y2. Let's say this cell is x1 y1 and this is x2 y2. Then the sum would look something like pref, and now this is a 2D array, so the notation differs slightly. Pref x2 y2, which is still here, minus pref x1 y2 minus pref x2 y1, which is this, and now we have to re-add this again. So plus pref x1 y1. That's what the 2D formula looks like. A similar thing can be extended to 3D as well, but that's not used as often, so I won't be covering that. Uh, do you all understand till the 2D pref sum part? Okay. Which part do you not understand? I'll repeat. Alright. So it would, like, I can just show you the code of one of the problems. It would look something like this. This is one of the problems I was going to be discussing later, but we'll just stick to this part. This is where the pref sum is being created. So it's a n by n loop, nested loop, and now essentially this is the value of, like, let's say if you were calculating this value, you'll go in this order. Like first you'll find this value, then this, and so on, like row wise. And so here what's happening is this value is equal to the value in the original array at that place plus the like it's very similar to the query one. Essentially it's just, if you're finding this value, then it's the value at this place is added to this, the value that you had already computed here, plus the value you had already computed here, and minus this, which would give you the sum of this region. And then you add the current I comma j value over in that value, and now you get the correct thing for that you can now put in the prefix sum 2D array. How do we pre-compute it to begin with? Like, it's just like, this is what the code looks like. You just take the input obviously, and then like I think that's what I just explained here, right? This is the formula, what it looks like. It's very similar to the query one. You essentially have to find the sum of these values, and then you add this current one to that. Is it clear now, or should I elaborate more? Um, Hello. Okay, 2D array is not yet covered. You can think of it as an array of arrays. The I think Samek told you to use vectors, so I'll use vectors. It's essentially like when you use vector. I think I should type this. That would be much better. When you use vector, you usually do this, right? Like this is the data type. Essentially, when declaring, you just instead of an int, you put another vector of int here, and now it's a list of lists. So I'm showing it as a grid, but essentially what it would be is this would be one element of the original of this array, and this would be the second element, the third element, and so on. And inside each element there are itself integers. So that's why it's like that's why it's called 2D array, because it's like a list of lists and it can be shown as a grid. All right. So you all got the prefix sum one as well, right? The code I showed and the how to make this array is actually very important. It's of course slightly more complicated than the 1D array one. That's why I'm trying to make sure that everyone knows. Query part. Query part is this formula I've written. I think I'll just create another diagram. Let's say this is your grid. Okay, and you want to find the sum in some sub rectangle of this grid, where this coordinate is x1 comma y1 and this is x2 comma y2. uh, are you all comfortable with using the word coordinate? Like, you know what it means, right? Okay, so here if this is x2 comma y2, I'll just call it point 2 and this is point 1, then this formula would essentially be like this element, the first element, is the sum of all of the values from in the subrectangle of 0 comma 0 to x2 comma y2, like this big rectangle. Um, then x1 y2 is over here, uh, this rectangle. x2 y1 is this rectangle, and x1 y1 is the upper left rectangle. So using those four values, you can find the prefix sum from point 1 to point 2, like this in this subrectangle, and that's like the formula. Uh, what's that?
When we are finding the prefix sum, we are finding row wise or column wise.
That's entirely up to you. Most people do it like row by row, like they fill in the values in this order. But that's entirely up
Ma'am,
to your.
but
Yeah.
if we take the prefix sum from the larger rectangle, it will also cover them from this adjacent sides also, like from the ends.
Uh, Ends as in like I'm not sure I understand what you mean.
Can like in the diagram, like there is one more. Let there is one more coordinate besides two.
Like somewhere over here.
Up adjacent directly in the same, yes, in the same row.
Okay. Okay.
So if we are taking this sum, if we are starting from 0 0 and calculating like the first in 0 0, then in 0 1, then in 0 2,
Yeah.
like that, so it would also include like the 0 x, but we have to, but the coordinate is like 0 x, like 1 x minus 1. But if we take the prefix sum from there, it also includes 0 x.
So I think what you are trying to say is, do you think that the value here would also include this element? Is that what you are trying to say?
Yes, yes, yes,
No,
yes.
yeah, like the writing the code part, instead of like just using one sum variable like you could have done in prefix, you're actually using the other values around it to get the current value. Like um, if you're finding this value like I showed here, then you're using this value, this and this in order to find this region, like the subrectangle up to this point without it, and then adding that. So you're not really maintaining a like running sum, as you were saying. Like let's say when you're finding this value, you would just not you would just completely ignore this one and just use this and this, like 0001 and 10 plus the original value at 1 comma 1 in order to find the prefix sums value at 1 comma 1.
Okay, clear. So for a larger rectangle, we can take a 0, 0 and the three adjacent points from that.
Yeah, like the left top and the top left one. You can use those three to
Okay.
compute the prefix sum value.
Okay. Can you show me the formula once?
The formula I'll just show it to you in the code. Uh,
Okay.
this is what it looks like. Like this is the current value. I think the naming convention is a bit different. This is for a specific problem, that's why I've named it this. This is the value over here. Like this is the value in the original array at this place. This I minus 1 comma j is the prefix sum value of this region, okay, which is added, and then I comma j minus 1 is the prefix sum value of this region, which is also added, but now this region is counted twice, so we have to subtract that, right? Do you understand that now?
Okay.
Okay,
I understood.
all right. So this is 2D. For 3D, the formula gets like it includes a lot more terms, and also I have never actually used a 3D prefix sum, so like it's never come up. So it's not that important, so I'll be skipping it for now. Uh, the next thing that I was going to go over are difference arrays, which are relatively closely related to this topic. That's why I'm including them here as well. Um, so essentially, a difference array, you can use a difference array when you have to do updates to your array. Like let's say your this is initially a zero array, although it doesn't have to be zero, but let's pretend it is. And a sample problem for this could be that let's say you will be given queries in which you are updating this array. Like you could be told to add like 3, let's say, to all uh, the values from index 0 to index 3, or index any L to R essentially. Like uh, the it's not a query anymore, it's an operation, and the operation is just it will take a subarray and add one element to it, add one value to all the elements in that subarray. Okay, so let's say this is like a problem. In order to I'm just giving you this so that we can understand the what a difference array does and what its uses are. uh, do you guys understand the problem? And if you do, then tell me how you would go about solving it. The problem is that you'll be given operations that you have to do on an array, and like let's say uh, you'll be given an index L, R, and a value X. So you have to add uh, like you have to add x to all the elements from index L to index R in your array, and then later on you will be asked, like as a query you will be asked what is the value at a certain index, let's say. That's the problem. Lazy secretary is far more advanced. You do not need lazy secretary for this. You'll be asked the like value at the end after doing all the operations. I'm not sure I made that clear. Yes, yes, this is exactly what I meant. Um what Divjot has just said. That's how you can go about solving this problem efficiently. So what he is essentially saying is that at index L in a like initially if the array is all zeros, then at index L in a array he will add the value x, and that at index R he will subtract the value x. So if you take the prefix sum of this array, then all the elements between L and R would be x, and after that and before that would be 0 after this one operation. And now you can just do the same thing for each operation. Alright, now this array that has just been created is known as a difference array. uh, Essentially it's just like it's asking for it's like the difference between these two elements in the main array that's being operated on. So you're saving the differences between two consecutive elements in this case. So that's how you're going through uh, like right difference array. So that's how you're saving, implicitly saving the uh, original array while maintaining the differences between two consecutive terms, because in this specific operation the differences would not change that much while the values would change a lot. Different not change that much means uh, like there will not be a lot of unique values in the difference array. uh, this was, yeah, they do both mean the same thing. um all right, so this is what a difference array is. uh, right. I've prepared a lot of questions on these topics, which I will now go into. If all of you are clear, then we can start with the questions. 2D as well, and you can, but I think it will be it will be a bit more complicated. Just the same way that 2D pref sum is more complicated than 1D. Alright, I'll just give a sample test case, sample case. Let's say you are given an array of zeros initially. Alright, its length is 6. Now you will be given operations. I'll just write the indexes as well on top so that it's clear. Okay, so you will be given operations of the form L, R, X, and you have to for each operation you have to add X to all the elements with indexes between L and R. So let's say you're given the operation 2, 4 and 3. This means that on the indexes 2, 3 and 4 you have to add the value 3. So this array would now become 0, 0, 3, 3, 3, 0. Like this is what would happen after the operation. Uh, and now you could add more things, like let's say 1, 3, 2. Then you have to add 2 to these three elements, which would make it 0 to 5, 5, 3, 0. Alright, this would be the original, this would be like the original array, but this is not actually what you will be storing. So after all these operations are done, the thing you're actually storing would look something like this. Like after the first operation, it would look something like 0, 0, 3, 0, 0, minus 3. This, and if you calculate the prefix sum of this, it will give you the correct original array. This one. Alright, so essentially you only had to update two values instead of the r minus l values you would have had to update if you were doing it like without any optimization, brute force. Alright. Yeah, so like let's say after the second operation the array just becomes 0, 2, and the 3 remains a 3, 0, and it was index 3, so at index 4 there will be a minus 2 and then minus 3. Alright. Yeah. Okay, so now I'll start with some of the questions. As I said in the beginning, I've sorted them into three categories. I'll just send all of the questions here so that you can have a look at them as well. And if like as everyone has a different level of skill here, so all of you can just like look at the problems, and if it feels too easy, you can have a look at the other problems as well. So I'm just gonna send these. The first three are relatively easy. The next three are in between, and the last two are slightly harder than the rest. Now I will be showing you the actual implementation as well now for most of these. So let's start with the first question. It's just the first question that I gave you for prefix sums. Have a look at it, and this has mostly been already been discussed, so I guess I'll just jump straight to the code. If anyone wants to have a look at the problem again and maybe like think about it, then let me know. Yeah, then you can move on to the other problems. In fact, I won't be discussing the middle three problems, the one I've categorized as medium, because like those are in between. If we have the time, I'll go to them. But if like you can read those, and if you have any doubts, you can ask me at the end of the class. All right. So the first question, it's just basic prefix sum, the one I told you in the beginning. This is what the code would look something like. At least this is how I implement it. So I think I should increase the size. Can you all see the code clearly? Last two are relatively hard. Yeah. Okay. So first we just take the input. I think that much is relatively like it's just old stuff. You already know that. So this is the prefix array. Um, the first value, at least this is how I prefer to implement it. Some other people make the first zeroth index as 0 and start from 1 and 1 indexing. I prefer to use 0 indexing. It's up to you how you implement it. So this is what the creation of the prefix sum array looks something like. Like I set the first value as the first value in the original array itself, because that's just P0 is just A0, because like up to 0th index there's only one index there, so it's just this one element. Now for when I is greater than 0, you'll take the pref I minus 1. This basically means all the sum of the values from A0 to AI minus 1, and then add AI to it to get the prefix I value. Alright. And as for the query, there is one thing that you have to take care of. Like in L to R, in this specific question it was written that you have to go up to Ri minus 1 from Li. So I subtracted R and then did like answers the prefix sum value up to R, and now I have to delete the values up to L without including L. So uh, like you could just delete, like you could subtract pref L minus 1, but if L itself is 0, then this would be pref minus 1, and that's out of bounds. That's why this is in an if. You have to take care of this in this specific implementation. You have to take care of this sometimes. That's why it's in an if. Like if L, this if L just means that if L is not 0, that's like it just works in CPP compiler. So that's the first question. I think everyone should have understood this question. If you don't, then let me know. Alright. So let's see the second question now. It's slightly different, still fairly easy. I'll give you like 1 or 2 minutes to read the question once. You can think about how you would go about solving this. I think uh, everyone, you can just open the question on your own. I've sent the link somewhere. It's there. And if you have any ideas, tell me how you'll be solving this question. Right. Yeah. So Advik, that is what you have to do. Yes, that's the basic idea, but how would you optimize it? Because if you do this naively, then it's like n square, and for n 10 to the power 5, that won't work. Yeah. So uh, um, okay. Yes. Yeah, that would be what the prefix looks like. Yes. So I think all of you are able to figure out what the basic idea is. I'll just show you the code once as well. This is essentially like you maintain a prefix and a suffix. So what you can do is in the prefix is just instead of adding your GCD, you're using GCD instead, and the same for suffix. Suffix is essentially prefix, but it instead of the first part, it's the last part of the array. So, and then as you all said, we'll try removing each element one by one. One thing you have to take care of is you also have to try removing the first and the last element. That's the only slight corner case in this question. Alright. So does everyone understand this question? Only three people have written their solutions. Uh, Not really. I think this is like pretty efficient. All right. Um, are you solving the question? Like, are you writing the code? Because that would take slightly longer. If you are, then I won't. Like, I'll move on to the next question. You can do that later on as well after the class. I'm just trying to cover like the concept of it. All right. Okay, so let's move on to the third question now. Um, this is a question about the difference arrays. So have a look at it once and try to figure out how you would go about solving it. I'll give you like 3-4 minutes. So go through the question and think how you would solve it. Yeah, this is just like a practice problem for those who have not done difference arrays before. Um, have you all read the question? Do you have any ideas? Add. Okay, try to think of it a bit more. Like, I'll give you a couple more minutes, like everyone else other than Advik. Yeah, the class recording would be given. Okay, I think I should go over difference arrays once again. Um, so I'll just do that by through the question. Um, so essentially, what the question wants you to do is be given a lot of ranges L comma R, which are like optimal temperature ranges, and uh, a, a specific temperature is admissible if it is used in k of these ranges. Recipes is essentially the same as ranges here. Uh, right. There was no problem in understanding the question, right? Like you all understand what the question wants, like wants you to do, right? Okay. So yeah, essentially, this is a combination of both the things we've learned, difference arrays and prefixums. So I think I'll draw. Essentially, let's say this is the range of temperatures. Let's say this is a thermometer or whatever. And you will be given certain ranges LR, where a recipe is essentially this range, and these ranges can overlap. Like let's say something, the input could be something like this. I'm not giving specific values because I think that's understood, right? Or should I give those? Mm, right. I think that's understood. So essentially, a specific temperature, like let's say this is also a range. Let's say this temperature is given in three of these ranges, right? And this specific temperature is given in two. This one is 1 and this one is 0. So the question has set a specific lower bound k which will be given in the input. And the question is saying that if a specific temperature is in at least k of these ranges, then this temperature is admissible, right? So this is what the question is saying. Now, if you have a look at the constraints, it's 2e5 for n and for the temperatures as well. Like the L and R are also up to 2e5 only. So, and you can create an array of length 2e5 without running into MLE issues. I think that should have been told at some point earlier, like in the earlier lectures. So now this is like you can do this, solve this problem in two steps. The first is essentially finding the array, like let's say this temperature is in 0 ranges, this one is in 1, this is in 2, 3, 2, 1, 2, 1, 0. So an array like this, the first step is finding an array like this of length 2e5, because 2e5 is the upper bound given in the question. Right. Now you can do this using the same difference arrays that we had discussed earlier. Like let's say, let me just take the sample input here. Um, just a second. So 91, 94, 92, I'll just copy this. And put this here. Alright, so this is the input. I'm just gonna sort of draw it. So one of the ranges is 92 to 94. 92, 94. Then there's a 92 to 97. This is also a range. And there's a 97 to 99. Alright. So these are the three ranges you have been given in the sample input. Now, essentially what you, in the first step, what you want to do is somehow have the information that like this specific number, like let's say 93, is included in two of these ranges. Then 90 is included in none, 98 is included in one, and you want to have this information. Although you don't directly have to save this information. Like this is the key thing. Um, right. So now you can do this using difference arrays, which is like it's identical to how we discussed. Like instead of being given L, R, X, like I said, it's you're given L, R, and X is automatically set to 1. You can think of it that way. So in this case, you would be creating a difference array would look something like at the 92nd index, there would be a plus 2, 94, 5, because you have to subtract over here, of course, not here, because 94 is also included in the range. So here at 95 there would be a minus 1, and at 97 is there would be a plus 1, while at 98 there would be a minus 1. Right. I think I've messed up some of the indexes here. Yeah, 97 is actually included in two ranges. The first one and the last one. I'm not sure if the ranges are inclusive or exclusive. They're inclusive. All right. So at 97, in your original number of times array, there would be 2, which means there's a +1 here and a -1 here. All right. And then at index 100, there would be another -1. So yeah. All right. So essentially, what the array you have created looks something like 0, 0, 0. Then there's a +2, some zeros, then -1, etc. And the prefix sum of this array, which is the key idea in using difference arrays. The prefix sum would look something like 0, 0, 0. Then there's a 2 here, and then this remains a 2 until the -1, where it becomes 1. Then 1 stays here. At 97, it gets a +1, so it becomes 2. At 98, it becomes -1 again. It becomes 1 again, like 1 gets subtracted, so it becomes 1. It stays 1, and at 100 it becomes 0 and then stays 0. So you essentially get this implicitly stored in your in the array you stored. Like you don't have this explicitly, but you have it implicitly. Like you can get this using some computation on the things you have already stored in memory, right? So does everyone understand till here? This is like the main thing. After this, it's relatively easy. All right. Huh. Okay. So now in the input, what was the k? K was 2. So this means that, like, let's say 91 temperature is not admissible because the value here is 0, while 92 has a value of 2, and K is also given as 2, therefore this is a admissible temperature. 93 is also, 94 is the admissible temperature, but 95 is 1, so it's not an admissible temperature as in the question. So this is now what you can do is essentially like you have this implicitly stored. Now you can go through this, like using the prefix sum of the difference array. You can go through this and create another array where if the value is greater than equal to k, then the number stored will be 1, else it will be 0. Alright. So this new array would look something like this. Yeah, and then zeros on both ends. So this is essentially giving you a list, not exactly a list, but like it's giving you the information of whether a specific temperature is admissible or not. Alright. Can someone try after this point? Like, I think there's just one step left. Can you think of it yourself? One of the people who've not already answered yet. Like, there were two who had already figured out the entire solution. Is there anyone else who would like to give it a shot? Yeah, like do the query, but because even if you do it now in naively, then it would be nq. Nq is n into q, like order nq, because you would be adding all these elements, right? So you have to optimize it. So, well, yeah, you can use prefix sums for this, right? Like just this array you have obtained, and now you have it like properly in memory, and you can just use prefix sums on this, and then it's just a simple query. It's like the first question we did after this point. Do you all understand that? Like, or should I elaborate more on the last part? Okay. Um, yeah, like the first question we did. So essentially, you can think of this new array that you have obtained as the input in the first question we did, and then you solve after that. Like you just apply prefix sums on this, and like it's essentially identical to the first code we did with this as input. You have to get here this, like, two or three previous steps have been included. R comes afterwards. The R comes as addition. It was A and B, right? Yeah, like the and L minus one and all, like that's just specific, like index plus minus one. You have to, like, very implementation dependent. Uh, in this case, I think it's just better to use like pref B minus pref A plus RA. Like the formula that Advik sent in the chat in the beginning, I believe. All right. Okay. So, all right. I think we'll go over the. So, do you want to do the medium questions or the hard questions now? I'll just go with whatever you guys want. This was like the easy. I consider these three easy questions. Okay, there's one medium and one hard. Anyone else? In their opinion? Hard. Alright. The hard ones are also not that much harder, so like it should be still fine. So this is the second to last question in the list I sent. I'm not sure if the list is still there. This specific question is on the easier end. Plus, these questions are like far more interesting as well. Like you would probably enjoy solving them. You have done the first one in hard. All right, let the rest of us do it as well. So everyone just open the forest queries, like the second to last question I sent. Uh, have a look at it. That's the first one. Like the CSES link would be the first one. Yes, I did. Um, but we're just gonna discuss it quickly, and then if we have time, we can move on to the medium ones as well. Has everyone opened it? If you have, then just go through the question and think about it. What time does the class end? Once we've covered like majority of the things, I think we can end it there. Like there's no hard bound essentially. I think in the after the hard questions, I'll just ask you all to go through the medium questions, and if you have any doubts, then we can discuss those. After that, we can end the class. Forest queries is essentially just the 2D prefix sum thing that I told you in the beginning of the class. If anyone has any doubt in it right now, then you can ask me. Although, honestly, I think if no one has any doubt, then we can just move over to the second problem in the hard section. You guys want to do that? All right. Okay. I'll explain it once again. Um, Essentially, what this question is asking you is, I think it's better to explain via the sample input. Um, Essentially, you're given a grid, an n by n grid, and there are stars and dots on it. The star essentially means there's a tree there, and a dot means a free space. So what you have to do is you'll be given a subrectangle, the as query. Like there will be a lot of queries, and you'll be given subrectangles, and you have to like answer as the number of trees in that subrectangle, and you have to do it this efficiently. Because if you just like um, do it naively, then it would be order n square q, because now it's n square because the grid, the number of values is actually n square, because it's an n by n grid, and n square q is far too much. Um, so I think, did you understand the problem? I All right. So I'll just go through the code one more time. I think in case anyone wants to, like anyone is confused, I think it should be good enough. Essentially, that this part is just an input. I'll skip it. What we're doing is creating a prefix sum array. This is the same piece of code I showed earlier, a 2D pref array creation. Uh, Essentially, it's taking the current value, and in the subrectangle from 0 0 to ij without ij itself, you're getting that sum via these three terms, and then adding the I comma jth term via this. Alright, this is the creation part, and the query is also pretty much identical. This is like from row to row is x1 y1, and from call to call is x2 y2, which you take as input, and then this is the same exact formula that I showed over there, except now I think from row is inclusive, so you have to do a -1 as well. This one is one index, that's why there is no no need to worry about negative indexes in this one. How it would look in 2D. Alright, so I'll just show it for this input, I suppose. Um, I think I'll just write it. I think that's better. So the array looks something like this, the tree array. This over here, I've just replaced the stars with ones and dots with zeros. This is what you have to create the prefix sum out of. It would look something like this. Um, this one is a 10. Right. So essentially, like, let's just take a random index. Let's say this one corresponds to this. It means in this rectangle, like from here to here, there are four ones. Like that's the prefix sum from 0, comma 0 to this I, comma j, which is 2, comma 1. All right. This is what it looks like. Okay. So let's move on to this, the last problem. In the list I've sent it, this is the last problem. Uh, Go ahead and have a look at it as well. This is one of the harder problems we'll be like. This is probably the hardest problem we'll be discussing today. Just have a look at it once and try to think how you'd go about solving it. And if you have any ideas, write it in the chat box. I'll give you like 5 minutes to go through the problem and think of something. Okay. Do you guys have any ideas other than Advik? I think Advik has seen the problem before. Um, this problem was also used in an inter-school recently, and Advik was there. That's why he has seen the problem before. Yeah. Okay. Does anyone else have any ideas? Okay, I think I'll start with the solution now. Um, so essentially, what this problem is asking us to do is find subarrays where the length of the subarray is the same as the sum of the elements of the subarray. This is what this formula means. I hope everyone has understood that part. Like, this is what the formula means. This is also written in text. So, right. Um. All right. So I can see all of you are using the um thing for R to L. I think there's actually like one slightly simpler way to think about it. Like, when you have to do from L to R, uh, you use the formula pref R minus pref L plus AL, right? So instead of this, in this specific case, it's slightly better to instead of going from L to R, uh, it's slightly better to go from L plus 1 to R, because this makes the formula slightly simpler. Like, initially the formula would have been something like this, right? R minus L plus 1. You would have been trying to satisfy this condition. But if you go from L plus 1 to R, like, I'm just renaming the thing, like, this is still a range, and this is like L plus 1 to, if you count the number of L plus 1 to R's that are valid, that's the same as counting L to R's that are valid. So if you do this, then you get a slightly simpler formula, which is like pref R minus pref L. I'll show the full formula first. Minus pref L plus 1 plus A L plus 1, right? But this is the same as pref R minus pref L. Why? Do you guys understand why this is the same? Like, essentially, this stores A0 plus A1 plus A2 till AL plus 1, and now we are just cancelling that AL plus 1 here. So this entire term would essentially just be A0 to plus A1 plus A2 up to AL, which is pref L. That's why these are the same thing. And now as we are going to L plus 1, this is supposed to be equal to R minus L plus 1 plus 1, which is just equal to R minus L. So we need to satisfy this condition now. which is a slightly simpler condition, because if you do some manipulation, you get pref of r minus r um, is equal to pref L minus L. So this is essentially the condition you have to satisfy. And now you'll notice both sides of the equation only depend on either R or L, right? Is this manipulation like to get this formula clear? Do you all understand that part? Like this is the main thing. After this, it gets much easier. Yeah. Okay. So now what you have to do is like any two indexes, like I'll call them I1 and I2. If any two indexes satisfy this condition, then they are a valid L plus L comma R pair, right? So essentially now what you can do is you can count the number of like pref R minus R would be some value. Let me call that A. You can count the number of indexes where the this value pref I minus I will be equal to A in another map. Like you can use a map or a array in this case because the constraints are small. If the constraint was something like if each number was not a single digit, if like it was still 10 power 9, then you would have had to use a map. But in this case, you can use an array as well of just size 10. So essentially what you would be doing is like, let's say for I1, the value pref I1 minus I1 is equal to A1, and for I2 it's also equal to A1. Then in your map, for A1 would be mapped to 2, because there are two indexes that get the value A1 for this formula. Do you understand till here? Uh, Hello? Alright. Yeah. So now what you essentially have to do is you'll have a map of these things, like a A2 will be, let's say, 3, then there will be some values with 1 and some will be 0 as well. Zeros just don't count in map, like you'll never be accessing them, so they're just like essentially not there. So now what you can do is uh, you can, like, let's say if there are one of the values is 3, then there are 3 C2 uh, possible ways to choose L and R from this group, right? Where the indexes like putting the index in the formula pref I minus I gives the value A2. There are 3C2 such pairs which would right, so 3C2 pairs, and for another value, like let's say it was 2, then 2C2 pairs. If there's just 1, then 1C2 is just 0. And now you can just sum over all these and that will be your final answer. You'd have to take care of modulo, I think, in this. No, you won't have to take care of modulo because it's just 10 to the power 5. So essentially the sum of all these values, like if there's k here, then kc2 for all k is your final answer. Alright? Do you guys understand that? This is essentially the full solution. You're supposed to print the number of pairs, right? The number of good subarrays, which means the number of good L comma R pairs, and each L comma R pair that satisfies this condition is a good pair. And now we're just using this, we have been able to count all such L comma R pairs, right? After the map, you're essentially like you're doing 3. If the value is 3, then 3c2 plus 2c2. If there was a 5 here, then 5c2, and all of these you'll be adding, and that's your final answer. All right. So uh, you guys do know what like the C stands for, right? Like 3 choose 2. Yeah. Oh, I'll just explain it once as well. I won't be deriving the formula, but NCK is the general thing. NCK essentially means that if you're given n items, identical, if you're given n distinct items and you have to choose k out of them, then in how many ways can you do this? And the formula is n factorial by k factorial into n minus k factorial. This is what the formula looks like. This basically just gives you the number of ways to select k items out of n initial items. That is what NCK means. And here we're using 3C2 and all. Okay. So this was the hardest question. Now, as I said, I've skipped over the questions in the middle, the medium ones. So if you guys want to go through them, then you can just read them, and if you have any doubts, then let me know. Or should we just go through them as well? What do you think? All right. Uh, okay. Um, we'll go through them as well. So everyone just open the CF question, that is question 4 in the list I've sent, I think. Yeah, I think we'll just go through this question. The other two questions are, I don't think, that important. This is the only question in medium that's fairly important. So we'll just go through this one, and then if anyone has any doubts, then they can ask. So, yeah. I'll give you like 5 minutes to go through this. Uh, do you guys have? Yeah, yeah. You can just share whatever comes to your mind. Uh, do you guys have any ideas? Anyone? Guys, if anyone has any idea, you can send it in the chat box. Even like even the simple brute force, like unoptimal one, you can just like send it in the chat box. Yeah, maybe this one should have been in the heart section. Yes. Okay. So yes, that's one way to solve it. Uh, think about the complexity of this method. Uh, I think it's order nk, right? No, it's order nm. But yeah, the point is it's like it's too slow. So we have to somehow improve the method of like using the xi comma yi queries, because the second part is using difference arrays is pretty fast, but you have to improve the way that you're doing the xi comma yi part. Like each specific query you're doing using difference arrays, so that's pretty fast. Uh, but you have to somehow optimize the xi yi as well. Think about uh, like essentially you can think about doing another difference array, but you would have to merge both of them somehow. So think about how you can do that. Any ideas? Okay, I think I'll just um, show you the solution. So essentially what you can do is you can use the difference array idea, but you can use it twice. Like first you would be using it on the operations themselves, like the LRD ones, like how many times a certain operation is being uh, done. In order to get that value, you can use it once, and then to implement the operation itself, you can use it again. So what I mean by that is, like, let's have a look at the sample input. Uh, so 1, 2, I think this is one indexed. This would mean that you have to do this operation and this operation. Then 1, 3 means you have to do the first three, and 2, 3 would mean you have to do these two, right? Uh, okay, now the first one is an array itself. So the first operation means these two, then these three, and then these two. These operations you have to do in that order, but the order of course doesn't matter because it's just a sum. So first you can use these to create a difference array that will give you the number of times this operation is done, the number of times this operation is done, and the number of times this operation is done. Now what you can do is, like, that number you can just multiply to d, and then you'll get a string of simple L comma R comma X operations that we discussed in the beginning, and then you just have to add that to this array. So this is like the gist of the solution. Um, there's just two people left, so do you guys understand what I'm saying, like, or do you want me to repeat? Alright, okay. I think then we can end the class here. I have discussed most of the problems. If you have any other, like, issues with the rest of the problems I gave, then implementation, I have not actually implemented it myself. I can just show you the tutorial code, but I think you can. Uh, I guess I'll show you the tutorial code and explain from there as well. Okay, this is Java. Right. So this is just the test case thing. Essentially, what he is doing. Uh, just a second. I think I've forgotten the input format or something.
Aviansh, if you want, you can just show them my code. I think it's pretty decent.
Alright, could you send me that? Okay. Yeah. So in the beginning, that's just the input. This is the initial array, and here this one has done a difference array outside as well. Like this is essentially the difference array of the initial thing we had. So like this is the prefix sum of this would be the initial thing we had. So yeah, and now the two place edit like the L pay plus x and R pay minus x will be happening on this array, and this already has the information of the initial array, so you're doing that on top basically. So we've taken the input operations. uh, hmm. Now this is what I meant when I said you doing it twice. This is how many times a certain operation is being executed. So x to y, when you get that as input, then that means that you have to add x minus 1 here. This is, I would have added to x, but I think that's just implementation. And then you subtract it from y. So essentially everything from x to y now knows that it has been that operation has occurred one extra time now. So you do that, and then you just sum plus equal to L. Yeah. So this is just the. I think this is an unused variable, right? Yeah. No, it's not. Right. Execute def is of course also a prefix sum array. I forgot about that part. So now the sum would essentially store how many times this operation is happening. So like if the d was 2 and it was happening 3 times, then the total addition would be 6, right? That's why we are multiplying that. And then you in the other difference array you just add that at the right place in normal difference array fashion, and then subtract it at the r. Now you have to do the prefix something again on this newly updated adif, the difference array of the final like output array, and you just print that. So yeah, that's the solution. That's the implementation of the solution. All right. So you guys understand that, or if there's any part you don't understand, I can just go over it again. All right. I think yeah, we should stop the lecture now. Thank you. Good night.